Hello everybody, I'm Dan. Welcome to my Java tutorial series. Throughout my tutorials I will teach you Java using just Notepad and the command prompt. The order in which my tutorials are organized on both my website at javacjava.com and my YouTube playlist is designed to maximize learning by building on concepts from prior tutorials. This tutorial is about the short class. I'm going to go ahead and open up my web browser to my website, javacjava.com, then select Begin. I'll scroll all the way down here to the short class. The short class is a wrapper class that wraps a value of a primitive short data type into an object. I highly recommend watching my primitive wrapper classes tutorial, primitive numeric type casting tutorial, and my Autoboxing tutorial before continuing with this tutorial. You will need to understand certain concepts from all of them in order to fully comprehend the material in this tutorial. It is important to note that the short class is immutable. The short class contains a total of 5 class variables that are essentially constants: bytes, max value, min value, size, and type. I will show examples of how to access these members, but type is beyond the scope of this tutorial series thus far, so no go. Constructors. The short class does not have a no argument constructor. The class has 2 public constructors: short, that takes a short value, and another one that takes a parameter as a string, right? So a short parameter and a string parameter. Methods. Now the short class has about 20 methods, so I won't list all of them here. I will demonstrate how to use some of the methods in the example code. Let's come down here and I'll highlight that. I got that off a little bit there on my alignment. I'll have to fix that on the website there. Hit Control C to copy, or right click and select copy. I'm going to move my browser off screen here. And I've got a shortcut to the command prompt on my desktop, but if you don't, you can create one really quick by right-clicking, selecting New, and then Shortcut. Type in CMD, Next, and Finish. Okay, go ahead and open up the command prompt here. I'm going to type in javac, which is the Java compiler command. You should see all this stuff scroll by, but if you don't, if you get an error message, watch my tutorial on installing the Java Development Kit. You'll make sure you get that installed and configured properly before continuing. CLS to clear the screen, then CD space backslash. CD is short for change directory, and backslash tells it to go to the root. I'm going to make a directory using the MD command called Java. I already have that folder, but if you didn't, it would go ahead and create it for you. I'm going to make another directory after I change directories to the Java folder. And I'm just going to call this short class, and Notepad short class.java after I change directories to that folder there. Okay, let me move this over here and Control V to paste, or right click and select paste. Alright, let's go ahead and save this out here. First thing I'm going to do is compile and run it, and then we'll just go line by line here. So I'm going to clear the screen, javac, and the name of the file I want to compile, Java, to run the Java virtual machine. And I want to invoke the short class method, the class. Okay, so we'll come right up here to the first thing here. Class variables, constants, right? So number of bytes in a short, and then displaying the short dot bytes, basically constant there, field, or class variables, whatever you want to call them. But there's 2 bytes in a short. Number of bits in a short dot size, right? 16. That's right, because there's 8 bits in a byte, so 2 times 8, 16. Math is all correct on that. The maximum value of a short, and short.max value is the constant for that, 32,767, and short.min value, which is negative 32,768. Okay, let's come down here to constructors. So basically, you got an I1, this is a short class type, setting that equal to the reference to a new short instance, right? And invoking the constructor that passes it a short parameter, right? And so I am casting this numeric, this integer literal 41 right here, I'm casting that to a short type, so that will match the parameter of the short variable coming in there. Primitive short variable, I should say, cast a primitive int literal to a short. Okay, and then I'm displaying that to the console there, so I1 equals 41. And then I'm using the constructor here to create I2, basically when passing in the string object type parameter, and displaying that to the console. So that's examples of how to use both of the constructors there. Now some common methods here. What I'm doing is I'm having initializing a variable called temp of short type, short object type I should say, and I'm setting that equal to 0. Now the 0 autoboxes basically the temp reference variable. Autoboxing will take 0 and turn that into a short instance object located on the heap. Same thing here, autoboxing that for temp2. Temp and temp2 are just basically reference variables, and both of them are referring to short instance objects that are located on the heap, two separate ones there. Okay, so that's important to understand. So the first method I'm going to talk about here is short value, right? And that returns a primitive type short. So, and it's not static or anything like that, so we can only invoke that by creating basically an object there. And that returns the value as a short. Now it may lose data if the short is outside of bounds. So here I'm setting temp equal to 41, right? And that's autoboxing it and changing it to a short instance on the heap there. And then I'm retrieving this variable b, which is the short primitive type. I'm getting the short, invoking the short value method from the temp instance there, and displaying that to the console, right? So we get short b equals 41, right? Now, Autobox will fail if it's outside of bounds, so we know that our maximum value up here is 32,767. If I try to set temp equal to 32,768, and I'll go ahead and do that here, clear our screen, Java C, we're going to get a compiler error here, right? Incompatible types, int cannot be converted to short, and that's when we're trying to set it to 32,768. Okay, so autoboxing will fail out in a compiler error if you try to assign something outside of the bounds of the short. So we'll rerun that. Okay, let's get back to where we want to be here. All right, now we're ready for the compare. All right. Okay, so the next thing we have is compare. So this is the method signature here. Two parameters, both of primitive short types, x and y, right? And that will return back an int, and it's a static method, so we can directly call it too. And it basically compares the parameters for equality. Returns the value of the first parameter minus the second parameter, subtracting the second parameter from the first parameter. Now this is nothing like the integer compare, which returns like 0, -1, or 1, you know, so this will actually return the differences out in there. And of course you'll notice that when invoking these methods here, we can directly invoke them, of course, because it's a static method, so short.compare, and I have to cast, you know, all of these integer literals here to short type, otherwise I'll get an error. So that basically, 36 and 36, there's no difference, 0. 30 minus 40, right, is -10, and comparing 40 and 30, the difference is 10. Okay, so that's the way that that works there. Now compare 2. Compare 2 is very, very similar, only it does not take two parameters. It takes one parameter of a short object type, right? And it returns an int value there. And so and it's not static, so you have to use this method from an object. You have to invoke it through an object there. It's sometimes called what's called composition. But anyway, so temp, autoboxing 35, and temp2 autoboxing 35 to those. And then I'll use temp.compareto and temp2, which will basically be 35 and 35, right? That's difference is 0. Then I'm changing temp2 and autoboxing it to 40. And so basically 35 and 40 by calling temp.compareto, because temp is still equal to 35, right? And that difference is -5. Then I'm changing temp2 and autoboxing the value of 30 to it, and invoking the compareto method there on the temp instance, basically is 35 and 30, and the difference is 5. Okay, so that's the compare to method there. The next one is decode, right? Where we pass in it returns a short, this actually should be a short object type there, right? From a string, okay? And it's a static method, so we can directly invoke it there. And the string parameter can be a decimal, hexadecimal, or octal, okay? So on the first one there, calling short.decode -328 passed as a string, and the string literal here, and that will just simply display -328 to the console there. The next string parameter I'm passing in is hex. 0x, of course, is a prefix for x, and that x can be an upper or lowercase, and then 2a, right? And that is equivalent to basically base 10 42 on that hex there. And you can also use a pound symbol in place of the 0x prefix here too as well, right? Same thing, 42. And octal, right, which always starts off with a 0, 0104 in octal is essentially base 10 or decimal system 68. So that's the way the decode works. It returns a short type there, okay, and receives a string parameter. Okay, double value, let's see, I'm going to go ahead and scroll up a little bit here on this stuff here. Double value simply returns a primitive double, right, from the current object. So you can see it's not static or anything like that, so I am autoboxing our temp reference variable to 23,900, saying primitive double type D variable equals temp dot, and then invoking the double value, and then displaying that to the console there, D 23,900.0. All right, then the equals here, right? So the signature for that is equals, and then we pass in an object, right? And that will return a Boolean. So return true if the value of the current object is equal to the value of the parameter. So got temp here, temp, and I'm autoboxing its value 41. And when I say display temp.equals, I'm going to have to cast it as a short type, because if I pass in 41, this integer literal, it's going to do some strange stuff. It's not going to equal it. And that's because I haven't gone over instance of yet, but basically an integer is not an instance of a short. A short is smaller, so we have to cast it here in order to get that to work properly. So what happens there is this right up here. Temp.equals 41 cast as a short equals true. Temp equals, and then if we pass in just 41, it equals false. Okay, and that's why, because this is an integer literal. Okay, float simply returns a primitive float from the current object. So I'm autoboxing 10,000 into temp, and then float primitive type f equals temp.float value, displaying that to the console, 10,000.0. All right, let's go ahead and scroll up on this guy here. Hashcode returns the hashcode for the current short object. Basically, it returns the primitive int value represented by this short object. And temp is currently equal to 10,000 up here. It's just going to basically say 10,000 right back to the console there. There's an overloaded method of called hashcode2 here as well, which is static, turns an int type back, and you can pass it in a short value to return the hashcode for that parameter value. It essentially returns the, that should say same thing. Same thing as the parameter. You know, not really entirely sure the purpose of this message, but you can see short hashcode, and then I'm casting -2399 as a short type there, and that equals -2399. So really the same thing essentially there. All right, int value returns an int primitive value from the current object. Pretty straightforward on that. It's still equal to 10,000, so I equals temp.int value, displaying that to the console, I equals 10,000. Long. Returns a long primitive value from the current object. Long, and then long var equals temp.long value, and displaying that to the console right there. Long var equals 10,000. Okay, let's come now down here to the parse short method. That one takes a string as a parameter and returns a short, and it's static, so returns a short primitive value from the string parameter. So short iParse1 and equals short.parseShort, and in this string parameter here, I just chose to put in the positive there just to show you that that's an optional thing. It's no different than doing that, right? But I just like to put it in there. So displaying iParse to equals and then 9797 there. Okay, so that's what the parse short does. Now there's also an overloaded method on the parse short here that takes a string and the radix, right? Returns a short primitive value from the string parameter, and the radix parameter is essentially what base numbering system to use, right? So in the first one here, short iParse2, I'm going to set that equal to short.parseShort. We're passing in a string parameter in which I've got a string literal of -620, -620, and the base 10 decimal system, iParse2 equals -620. The next one here, I'm parsing out 0271, and that is in the octal base system there, the octal numbering system, and that is the equivalent to 185 in the decimal system there, base 10. Okay, the next one I'm doing for parse short is -2C78, and that's a hexadecimal number passed in as a string, right? And that basically is -11,384 equivalent in the decimal or base 10 system. All right, we're getting here. Short value returns a short primitive value from the current object. Here I'm autoboxing 10,000 into temp again, and short S1 equals temp.short value, displaying that to the console. S1 equals 10,000. ToString returns a string object value from the current object, right? So here I'm just autoboxing 10,000 into the temp reference variable again, or more accurately, the instance on the heap that temp is referring to. But anyway, string ts equals temp.toString, right? And then displaying that to the console, ts equals 10,000. Incidentally, that's no different than if I did this, right? That's essentially the same thing. The .toString is basically the return back when you do the temp on that. So maybe not necessarily, but anyway, the ToString method will return the string back of the current value of the current object there. Okay, so displaying that, ts equals 10,000. Let's go ahead and come down here to the, and ToString has an overloaded method here, right, which is static, and you can pass it a short data type and it'll return back a string object. So string ts1 equals short.toString, casting this as a short 32,767 and displaying that to the console, 32,767. All right, the last one here is value of, and it's overloaded. The value of method has 3 overloaded methods here. The first one takes in a short type and returns back a short primitive type and returns back a short object type, right? So temp equals short.value of, and then I'm casting the integer literal 118 as a short type and getting that value back and displaying that, right? Temp equals 118. Okay, on the next one here, this one takes in a string parameter and returns back a short object type, right? Temp2 equals short.value of 19,178, right? So, and that's temp2, 19,178 over here. The last one, last overloaded version of the value of method here takes in a string parameter and a radix parameter and returns a short object type there. So temp3 equals short value of, and I'm using 1200, string literal, and then 10 for the base numbering system. Temp3 equals 1200. And the next one here, I'm passing in a 2C13. You'll notice I don't have the 0x on there, and that's not necessary because I'm specifying 16 as the hexadecimal base as the numbering system and the radix parameter there. So 2C13 is 11,283. And for the last one down here, I'm passing in 8, which is the octal decimal system, or the octal numbering system, not decimal system. 10 is the decimal system, but 0.0617, and that is equal to essentially decimal 399. Okay, I am going to go ahead and close out of that. Get rid of that, close out of that. Leave you with some final thoughts here. So the short wrapper class provides you with the tools to easily convert between objects and primitive types. That concludes this tutorial. Thanks for watching.